So let's go very basic, very foundation. So this is the part where we find. See? Yeah. Right. Okay. So this is very simple. Okay, this is as simple as it gets. Okay. Definitional. Data. What's data? No, I should hide it first. What's data here? I mentioned earlier, right? You can start thinking of data as tables. Yeah, tables. But actually, tables are already a formalized way of data. But you notice it has two things. It has two axes, right? One axis is called attributes. Okay? Attributes. The other axis is basically data entries. So first of all, data has to do with some kind of numerical attribute or measured attribute. Now, when I say numerical, in this case, I say P is a number. Okay? Because I'll talk to you a little bit. But numerical attribute meaning quantitative. Okay? So, for each field, what is the most important thing? This sounds like obvious, because that's what we're talking about. If you go down each field in a table, you have a table of data. Guys, pay attention. If you look at the table, how do you data? Okay, and you can take a field, I don't care, just take the data from the last Excel or something. If you go to one column, what is the thing you're guaranteed to see? Well, what you guarantee to see is that when you go down the entries, there has to be more than one there. Yeah. So those values are what I call measurement. And the attribute is also made in the table. So if I measure color, I measure color shirt, the result of the measurement is white. Okay, I call that measurement. Okay, I call that measurement. If I say the color of your mask, the measurement is green. Now, obviously, you more traditional way of thinking of data entry, and under this column, there will be some guy under this column, there will be some guy 5 foot 5, 5 foot 10. So the first thing is, it is a measurement. So the first thing is, it is a measurement. You can see. What else you can see? Rapidly pick up extra 5 of the dashboard for it has to be more than one row. Obvious, right? Right? So it's not a measurement of one guy. It is a measurement of sample. Okay, sample. Now, if you go about something like right? So you know that this pertains to client. That's what I call population. Okay? A population is a collection with a defined attribute. That is not perfect. Sorry, that's not specified in the file. Let me go ahead and let me verify that. If you open the file, right? Open the file. And under column 6, you see that there are more than one element, male and female, correct? That's a measurement, right? I mentioned 6, and the result is male. The result is female. So it's more than one element, correct? And then there are more than one person. But what if I close that file and the name of that file is my female employees? Are you going to find, well, Are you going to find columns that say sex? You could, but that'd be redundant, right? Because everything would be female. So attribute the characteristic of individual as well as characteristic of population. Okay. The difference is the characteristic of the population will be shared by all the members of that sample. Right? So the population is female. The sample is a female employee on my payroll as of 2019. That's very specific. But still, the femaleness is the characteristic of the population. Therefore, the sample, I'm going to find that as a measure, right? So that's a little bit of that. Like I mentioned earlier, you have a big database, female, age 35, 40. You're not going to find all of that say, I'm going to be 35, 40. Everybody wants to be 35, 40, right? But because we do the extraction, there's going to be a column that say, I need to be 35, 40, and all yes. But it's from the bigger data set and get people from another age group. Okay, so big data, data analytics, I have to admit, one guy. Okay, I'm going to instill some discipline. No walking in and out randomly, okay? You're free to think, you're not free to behave. Okay? So tell your friends. So do all your bathroom break when everybody does a bathroom break. Okay, so data refers to measurement of references. So now let's use the word reference one. Okay, references pertain to specific samples of entities or series of events. Now events is also a population. Okay, but so basically there are two concepts here: population like people, and then also population of events, crisis. That pertains to general population, people, male or student, or phenomenon, right? Okay, that we wish to do something about. And that do something about basically characterize the three problems. You either want to model it, control it, or you want to optimize it. This is a technical term: model, control, optimal control, and optimize. And each one is an individual point. Okay. So have in your mind. I want you to do two things. First, have in your mind when you talk about data. Think of the spreadsheet. So you have entries that pertain to one individual. That individual belongs to a sample. Then that sample is defined by population, and it has certain measurement that you know about. It doesn't mean that person only has certain attributes. No, you only know about that. You only know about age, but you don't know about weight. Okay, so what are the data attribute dimension? Now. Okay. I'll talk about model control optimization later. So what data science? Now data science. Again, read the excerpt that I put in mind. We'll talk about data science profession. But as a science, basically you can think of it in a couple of ways. Okay? First, it's about how data is generated. Okay? Data is about studying phenomena. make a hypothesis. So it's a data. In this case, the optic of the analysis data. See what I mean? When you do scientific experiment, you get experimental data and you make a visualization of that. Well, in this case, data is not necessarily data, it's the subject of the experiment. Subject scientific investigation. Why do we have so much data and so forth? Yeah?
And how it's distributed. Now, second part is the information that it contains, right? Information that it contains. Now, the information that it contains,
when we talk about mathematics, you understand a little bit more. Let's say that I'm taking information about your hair color, or whatever. That in itself is information, correct? But if I'm going to make a model that uses hair color to predict, say, your ethnic background. That's a second level. It's another layer of information, right? Okay. So the first would be something that you find the statistical analysis of distribution. Like how many people have black hair, brown hair? But that would do things like classification. Then we use hair color as prediction whether or not you are Caucasian or from this ethnicity. Right? You can do that. Okay? And this then becomes the basis of supervised learning. Okay. So the information inside that is contained in that, and the third part is where we manage a lot of practice is how do we go about extracting? So it's not that you have phenomenon of data aggregation. You also have the study that's the information useful, and if so, how do you extract it? The kind of transformation, the kind of machine learning model is unique. Okay? And finally, there's this thing called non-reliable information. Now that sounds a little bit like fluidism. Yeah, you don't know how reliable, but actually it's very accurate. You can in fact, it's based on that. Reliability is not whether or not you can have reliable data. It's whether or not, for example, model you use data in your network, and the data that you rely on has internal consistency, so that there can be no conclusion. Like I study this population, and they say, cannot predict ethnicity. But then actually out there, or here, analysts predict ethnicity because I'm you dye your hair. And I use this model to look at the population that people dye their hair all over the place. So it's no longer valid. But the reliability, in other words, can you rely on the data? So that's why there are actually 4 ways here, right? Phenomenon itself. Okay. How they are distributed, that will be a statistical analysis. Okay. Information or insight they have. How do you get them? And how do you use it? Really 5 areas. So when the excerpts are talking about potential, basically it's that third chemical about extracting safe information and insights. Right? I said the introduction that was about learning data information, insight, better decision making. Right. So this is the bit that we're going to focus, right? So data refers to measurement, but it's not measurement of one guy, right? When you want to know how to please your mom, you want to find everything about her, what she likes, does she like tea, does she like tea with milk or whatever. That's not data because you're actually interested in the subject one. Right?
But if you want to know what elderly ladies prefer, because you're setting up a business that caters to a nursing home or resident, well, that's data. Then your mom becomes one data point. Your aunt is another data point. Right? So data, yes, you think two dimensions, right? Not dimensions, sorry.
Because technically data science, every level of dimension. Two axes.
Right. So data science is referred to those 5 things. So what's analytics? Analytics is a relatively new term. In fact, it's only been used in the last decade.
Basically, it's about a suite of tools. Yeah? Remember I told you, human beings, the reason we are motivated to calculate that fraction. Well, that fraction is by way of making it as well, right? You done this distribution and we call hammer. You use stone, we call hammer. And in fact, you don't have stone. You have stones that make a stone. That's a stone. You use a set of stones to make stone pieces. So you have this level to make. In software engineering, you do one thing, but two series of functional calls. Each of which has almost a different job than you like sorting or something like that, or matching patterns. A neural network, deep learning, you're going to learn about it's built on layers and layers of computational layers. Flow, process layers of data. Each of them is layer of abstraction on top of another. Your connection is understood. Oh, but you don't see this. There's a lot of warning pops up here, but it doesn't show. That's good. Right. So data analytics. Yeah, analytics. You want to produce insights, information. Data analytics is emphasize the fact that you base all this on data. Data is the beginning and the end of everything. Let me say that again. In this area, data is the beginning and end of everything. It's the beginning because when you explore data, such as like visualization tools we can use today, you form your hypothesis. For hypothesis, and test your model, evaluate parameters, use your neural network, and when you're done, you have to validate it. You get tested. And we have a PD model. This one is elegant. It's beautiful. I created it. This one is boring. It's created by second years ago. Okay? But the data say this one has high accuracy, high repeatability. What do I throw out? The beautiful one that I created. So the data becomes an arbiter of goodness, quality of an analysis. So the data analytics is not just analytics, it's analytics that we give data. Those are analytics. Right. Quantitative emphasize that the stuff that you study is quantitative nature. Now, what's important about that? It's one of those things where you can map things into quantitative. In fact, you can map it into numerical. Then you can avail yourself to the most powerful abstraction engine that humanity has created. That is mathematics. So actually, you would prefer to work in an area where data is not just a measurement of PP, male, female. I can be that, but you would rather work in an area where the penis is 1.75, the happiness is 1.2 old. That sort of thing. Because then you can tell algebra. And you give a pre-view of what's called natural processing. Think about this. You have words that describe man, woman, shorthand, or so forth. Right? And the classic example, which I'm going to use, this classic example is, if you have those concepts, that's a linguistic concept. You have to know algebra. But if you can translate man, woman into vector numbers, you can do algebra. And when you do algebra, you add A minus C equals E. Then you map it back into the original concept. So what happens in the classical example that is used is man equal one vector. King, another vector. Woman, another vector. Now it's our equation P minus man plus woman equals some vector. Take that vector, map it back, and then it will be. So you can do algebra. Okay. So, those of you who are mathematics, well, I'm sorry, because mathematics was the most powerful thing to have. Okay? You can do that. That's what we did obviously do that, right? And minus we do that today. But imagine if the computer did that. And you did it now do that. That's why you do all kinds of stuff. You can generate video, face environment, and take your motion. Well, take a motion, get the question, my face, so that's how that's all mathematics. But I have not face mathematics. One mistake is mathematics. Motion is mathematics. So the point is, if you can use mathematics, it's how there is. Now, digital data concept here is what's digital data? Well, the digital data comes simply because one is digitized, capability, right? It's not digitized, you have to memorize it, right? Yeah, and now, whereas computers, if it dies, all you have to do is take a copy. Right. So that's where the digital. So it's a confluence. It's not just technology, mathematics, but also the technology. In other words, all the mathematics here would be understood by university level mathematician 200 years ago. More than that, 300 years ago. But that didn't happen then. Because you did not have, we did not have it 50 years ago because computers were too expensive. We have faster data, faster of communication, right? So it's a whole bunch of things that come together. So it's not an innovation of techniques here because this is actually very old, but a lot of it is economics. A lot of this would have been doable in the 70s, but the computer was too expensive. And you would have to scale, basically. What I'm now is too expensive. I wouldn't be able to do it on my laptop. Yeah? I remember when I was a PhD student, we have to make a graph, turn it into slides, and then use the overlay detector like that. You couldn't not see a line directly to the laptop. There was no thing in that laptop. Well, I did buy one for 1,500 pounds. Huge. It's NVIDIA 586 or something like that. I still have it. Right. So what's big data phenomena is the possibility to talk about that. Machine learning, okay. Well, what's learning? I'll give you a little bit of this. Maybe since you guys don't have a mathematics, I can't give you the file. I have to convert it to CDF, computer format. Then once you have the layer, you open it.
This learning machine, machine learning. Now, good thing I want to stop here.
This is the problem that I mentioned earlier. There are actually three problems with our life. One is modeling, right? One is optimization, one is optimal growth. And this is called operations research. So I guess that I students, you know, major in physics, economics, and math, whatever, operation research, very practical. Basically, one is modeling is supervised learning, all this is called modeling. And all this is called modeling. In other words, I want to model a representative model is a toy. Model is a toy. But it's a realistic toy. Okay? Moreover, the toy thing that has behavior. If I make a toy model of you, okay? Because you see a little stick here, right? That's a toy, right? That's like I have the big industry that does toy figurine or something like that, right? Okay, that's a toy. This is a model. You can't do much with it. Okay? Because it looks like, but it doesn't behave like that. On the other hand, like crash, you're eating here. Your schedule, what you do Monday, Tuesday, Wednesday, and then creating another toy. That toy has physical representation. It's a computer program that say, if today equals Monday, and yesterday equals pizza, predict what you will eat today. That is the toy, because it represents, right? But it's realistic. It's not realistic the way it looks, because it's not a little big figurine made rubber. It's actually a function. Okay? So I say this guy, okay, predict eat. We do it, pizza, and then I check what do they order today. Okay. That is a model. Now, why do they make a model? Because what? Prediction, right? And more importantly, think about traffic model. Let's say I have a traffic model of and I want to say, let's try this. Let's say we turn the green light, let's turn all the green lights on screen at the same time. This is my model. Right? I think it's a good idea. If I don't have the model, what we're going to do? Find a real thing. Right? Obviously, that means because it works, then you get traffic all over the place. But if I have a toy model of the traffic, I can simulate. So, the beauty of the toy, in this case, the model, is realistic in the way you want to use it. And the way you want to use it is to A, predict what you're going to get, or B, simulate what will happen to traffic by using the outcome of the lights. We like to get over alternative. That's what the does. It allows us to make the real thing to visit in mind of where anybody. What's optimization? Well, just now, when I say, let's try different lighting algorithm. I can describe it as an experiment. But if I say, I have in mind that my idea is to free flow traffic, then I have objective. And optimization, just do that. If you have degree of freedom, in other words, you can turn the light out and off way to this, that, and there's three parameters, and there's some things you prefer. You can tweak this control knobs to get the best light you like. That's my optimization. Well, optimal control, we can talk about it a little bit. Okay? No more samples. In fact, right? Okay? I dress well, we can respect, we give you respect. Okay? Right. Well back. Okay. Optimal control is a little bit not intuitive, but I'll give you an example. If you have a void, maybe you play some games, or maybe more than 8. Okay, more than 8, we have an objective. Once it's more than that, what if I want you to keep lasagna warm? Okay, keep lasagna with the criteria, and that criteria is warm. Okay, but I don't want to cook it. I don't want to make it as hot as possible or as cold as possible. I want you to keep lasagna warm. But lasagna will have the tendency to get cold. If it turns heats up, it will heat up. And at some point, it will burn. So, how can you guide it into this narrow channel of temperature? Not too hot, not too cold, dynamically. That's the key word, dynamically. Right? I don't want you to achieve a warm pizza in 5 minutes. And after that, it can burn or get cold, I don't care. That's not the point. I want you to keep lasagna warm between 3 p.m. and 6 p.m. Okay? Obviously, lasagna is you can just turn the heat up, the one maybe leave it. But a lot of problems are more complicated than that. What is an economy? What's an economy? An economy is an engine, right? You put some input, it does something, it has side effect, it turns on itself. What's the fuel of an economy? Money. The Bank of Thailand. How does the Bank of Thailand inject money? Well, lowers interest rate. How does the Bank of Thailand take the money away? Increase interest rate. Like white under the math screen. Now we're going to talk about numbers. So I'm not going to talk about green, white. But what if I want to talk about green and white in number? I have to assign, right? So the only thing now, let's say white and green is not, one is not better than the other. Yeah? I have to assign different numbers to that. So I can assign green to number 75 and white to number 102. Can I do that? Yes. Does it satisfy my purpose? Yes. Because my purpose is to identify white from green, right? That's called nominal scale. Yeah. Same with your student ID, right? Your student ID may be higher than this, but doesn't mean you're smart or whatever, right? Unless the college admission just rank you when they come in. I don't know. It should be random, right? It's not even ordered. So it's ordinal. That's all right. Nominal. Nominal means name. Nominal. That's it. All you can do is, now this is where mathematics, what is the, I would ask this question, what are the legal operators? Allowable operators. What can you do with the numbers? You can do this. Right? You can check for equality. And you can declare inequality. That's the only operator. Right? Oh, okay, let's draw some picture. Yeah, it's เอาเป็นแบบไอ้ที่เหมือนอย่างนี้ได้ไหม Okay, so all you can do, oh that's nice. So all you can do is I have to learn this. Okay, how do I erase? Okay. Now, what else can you do? Not much. That's it. Okay. Now, I'll give you one word, and you learn about this later. In machine learning, how do you deal with things like this? Normally, in neural network, you do what's called one-hot encoding. If I have 5 different values possible, and 5 possible value is 1, 2, 3, 4, 5. Okay? The neural network would tend to have 5 nodes, 1, 2, 3, 4, 5. And if I want to identify this color, or this person, or this number, whatever, this attribute, this one will be 1, and everybody else will be 0. It's called one-hot. Like, for example, boy, girl have 2 nodes, right? And 1, 0 means boy, not girl. 0, 1 means girl, not boy. Now, with boy, girl, why not make just 1 node, 1, 0? You can. You can, because you have 2 classes. But one-hot encoding works for any number of classes. So you have 10 classes. Okay? If you have 10 classes, you might think, well, let's make one output. And if output 1, 2, 3, 4, 6, 7, 8, 9, 10, it turns out to be very inferior in result. So what you have to do is 1, 0 output. So if I have 4 classification, that would be 1, 0, 0, 0, 0, 1, 0, 0. Okay? So that's called one-hot encoding. That works when your target variable, your y, is nothing more than nominal scale. Now, next up meaning more information rich. What if it's ordinal scale? Ordinal scale means 1 is better than 2 is better than 1, 3 is better than 2, or 1 better than 2, 2 better than 3. You guys, what's your experience with nominal number? Well, if you have like a beauty pageant, right? Right? The one who wins the beauty pageant is number 1, correct? The second is number 2, correct? The third is number 3, correct? How much more beautiful is the winner to the second person? No. Right? No. Okay? So, you know that the first person is more beautiful or whatever, more talented by the second one, because that's the winner, and the second one by the third, right?
how much prettier the pattern is. So it's one more than the other, right? So that's called ordinal number, ordinal scale. So the operator you can do is this, or maybe this. Okay, right? That's like ranking. Now, next, okay, you have what's called interval. Interval means interval in between, right? You can measure the distance. Okay. You can say that the first one who won the gold medal runs 0.037 seconds faster than the second one, right? So when you watch Formula One, even though the grid comes when they do qualification, qualify who runs at the beginning, that's what? That's ordinal, right? 1, 2, 3, 4, 5. But actually, you have more information than that. You have interval because you lap this Monaco in 2 minutes 3:025 versus 3:027. You know the difference exactly, so you can take subtraction. So now you can do this. Plus or minus. Right? Minus. That's called interval. Now, the interval is a bit like linear, but you don't have an absolute zero. For example, temperature. Okay? You have zero? Do you have absolute zero? Actually, no. When you measure in centigrade, that's not absolute zero. Okay? You go below that. The reason you call it 0 centigrade is because that's when at 1 atmosphere temperature, meaning sea level, right? It's the temperature that water freezes. Right? It's a different temperature that water freezes when you go up the mountain. That's another story. Right? So at 1 atmosphere pressure, the temperature that gives you the, transition, phase transition between water and ice, that's 0. But in America, they do things differently. Not necessarily more clever, just differently. So the ice freezes at 32 degrees Fahrenheit. So can you say that something is twice as hot because the number is twice as big? You can't. Yeah. But you can certainly increment 2 degrees difference, 3 degree difference, but you can't. So this is where we are. This is called interval scale. But what if there's an absolute zero? Then you can certainly do this. Right? Because you have 0. And then ratio. This is called ratio because when you can divide something, you create a ratio. Okay? So you are exactly 1.23 times as tall as you are. Because I take his height and divide by your height. And there is an absolute 0 height. Right? Anyway, so that's that. อ๋อมันทับกันแล้วเท่มากเลยเดี๋ยววันหลังเรามาเรียนวิธีทำมันต้องมีวิธีที่ฉลาดกว่านี้มันต้องแบบทำสกรีนทำ okay right let's go back to our presentation okay and this is okay right so data different form of data. Now, I told you guys that this is where the second part, the second V in big data variety comes in. So think tabular data because it gives you the 2 axes that you're going to be working with. And the idea that
do some kind of measurements, some kind of attributes, some kind of things you want to know. And for each of them, obviously, you can have many sample points. And the point of it is that the values are not the same. But the value themselves, if you put it in Excel, you put things like color, red, green, blue, right? But you can't do that with computer yet. You have to turn it into a number. So you have to create a map. Red equals to 1, green equals to 2, and so forth. Okay? Same thing. So think of Excel, but now you're not allowed to put in text. You're not allowed to put in picture. You're not allowed to put in anything. You must put in numbers. Then you have to think about this number scale, right? So, for example, I can say sex is what? Is the crudest form of number because not only is it nominal, meaning 1 is different from 2, there are only 2 values, right? So I can say something like male and go down the column and decide 1 or 0. 1 is not better than 0, but 0 and 1 are different. That's all I can do. And there are only 2 options. So you can say that in nominal, the smaller class is binary. Okay? Except people don't normally say that because sometimes binary has ordinal meaning, meaning 1's better than 0. Obviously, if you want to sell your product, 1 being buy or sold, and 0 means no sale, you obviously prefer 1, right? Okay. And in large part of my career is credit risk modeling. 1 means bad risk, bad credit. So 1 bad, 0 is good. Yeah, 0 is good, 1 bad. So now database, okay, this is more generalized because instead of having just 1 number, they talk about text, again, text is data, right? It's not numerical, you can't do math, but like I told you, with natural language processing, you can text to math, you can do math, text. Image, audio, video, network protocol, a lot of data in big data is computer language. Not computer language that you program or I'm teaching you mathematics or Python. It's what computer talks to each other with. It's computer protocol, like network request. You can actually use that as data. And a lot of data science goes over that. For example, in network intrusion detection, I had a project that got started in character. It was about monitoring network internet traffic and trying to see if somebody's trying to hack into SCP. So, like forcing some kind of network protocol. So this is the entry is not height of a person, sex of a person, education, income, but the actual computer commands that the network the computer uses to talk to each other. So the protocol